today we will deal with ecological economics. A thank you to Lily Falconer, a PPE graduate from a few years ago who has studied circular economies. Lily tutored a few years back in Pole 1 PPE, and I've incorporated several slides that she prepared on ecological economics for that unit. I've made some my own and some I've used without change. So I'm acknowledging the work that Lily Falconer did. And I've drawn on that expertise here. So as we've done in previous weeks, our approach to the material is to begin by speaking about the problem that the ecological economists have shouldered, and then to speak to how they responded, to map out the methodological approaches to the problem of ecosystem collapse and climate crisis, and then also to deal critically with the material by applying Stilwell's theories to Stilwell's questions to theory itself. Who gains? Who loses? And does it matter? So let's begin. The problem is immediately personal. I'm sure you feel it too. It's certainly historical, and interestingly, it's conceptual. We'll notice that the economic approaches that we've studied so far in this subject are in part responsible for the very production of this as a problem for us. So let's turn to the problem in more. How is the problem of ecological devastation, ecosystem collapse, and climate crisis a personal problem? Well, I'm sure you all feel it. Being younger than me, you'll feel it more intensely. But I also have children, so I have a very intense experience of this as a problem as well. Perhaps 3 years ago, maybe 4, I took my 2 little ones to a climate strike, the school's climate strike, and we designed posters together. You can see that my oldest child, I think they were then 6 years old, designed a poster that said, "We have only one world." This is truly an ecological and economics sentiment, as we'll see. And then my littlest one, I think they were 3 at the time, drew what they told me was fire. Very presciently, fire. Of course, being somewhat of a nerd myself, my poster was, "I think, therefore I protest." And my partner's was intergenerational justice. So this is a deeply personal problem. It's an interpersonal problem. It's an intergenerational problem, the problem of our times. But it's also more than an interpersonal and intergenerational problem. One cannot but feel that our experience of this problem as interpersonal and intergenerational is also skewed towards our own existence that dates back to a particular Enlightenment way of thinking about ourselves and morality as an interpersonal problem between persons. But watching David Attenborough's series, and you would have potentially grown up with The Blue Planet. You're too old now to have grown up with Brian Cox's The Planets, I guess, but I've been watching them with my children. What we experience in these documentaries are incredible tales of the unique nature of our biosphere and the fragility of life on our planet, and a comparison with life of other planets in our solar system and our universe that allows us to see just how unique we are. So, to depict this problem as an interpersonal or intergenerational problem is also a product of an Enlightenment way of thinking about ourselves and about morality as necessarily formulated in terms that another person can accept as reasonable for them. But these documentaries, these fantastic documentaries which have spawned and promoted the environmental and ecological movements, have forced us to think about our problem well beyond responsibilities to another person, but also to other life forms. And that's a very deep challenge, the challenge of trying to overcome our anthropocentric way of experiencing this as a problem for us. It's a deep challenge. So that's just a short reflection on why I do think it's a personal problem, but one that exceeds the interpersonal and challenges us to think about our moral obligations, not to other people, but to other entities and ecosystem on which we depend and which depends on us. The way that our species, humans, have made use of natural resources has changed dramatically in a very short time, relatively speaking. We now live in a very full world, and not the empty world in which Marxian and neoclassical economists formulated their ideas, and classical economists too. So without changing our economic activity, it's likely that our world will experience ecosystem collapse. We know the effects: climate change, environmental degradation, and biodiversity under threat, to mention just a few of the key ones. Let's consider the effects of the Industrial Revolution on our world. When we presented the Industrial Revolution in dealing with Marxian and neoclassical economics, we presented it in terms of changing modes of production, a shift in life from rural country living, where one produced what one consumed in families and households, and with increasing variety in the type of goods that were being produced, an interlocking, networked economic system of production, distribution, and increasing consumption into the late 19th and early 20th centuries. But what were the effects of the Industrial Revolution on our world, on our climate, on our ecosystems? That we haven't considered. Here is a depiction of just how much of an increase GDP per capita we've experienced, thanks to or because of the effects of the Industrial Revolution. So you can see that across 1700, 1800, 1900, we finally saw in the early parts of the 20th century the mass production of domestic goods, the mass production of labour-saving devices in North America that then extended throughout the world. The Roaring Twenties was a period in which factories produced more and more goods for domestic consumption. And we can see this in a table, the graph shows just how much production associated with these changes increased. We can also see how the size of the world's population has increased massively in only a short time. We can see too an increase in energy consumption across the world as well since the 1850s. We can see the breakdown of the type of energy being used as well. So with this massive increase in GDP accompanied by massive increases in population supported by increases in energy consumption. We note 3 effects at least. The 3 effects we will consider briefly here are climate change, environmental degradation, and biodiversity under threat. Here we have a graph that shows you just how much the emission of carbon dioxide has increased. So for millennia, atmospheric carbon dioxide had never been above the line that you see in this graph. However, we now see a dramatic increase in that amount, the amount of atmospheric carbon dioxide. And it's well beyond levels the world has ever experienced. What is this doing to our planet? Let's consider that on the next slide. So what is this doing to our planet? Well, according to NASA, the planet's average surface temperature has risen about 1.9 degrees Fahrenheit or 1.1 degrees Celsius since 1850. Most of the warming occurred in the last 35 years, with the 5 warmest years on record taking place since 2010. Global sea level rose about 8 to 9 inches, 21 to 24 centimetres, since 1880. The rate in the last 2 decades, however, is nearly double that of the last century and accelerating slightly every year. Since the beginning of the Industrial Revolution, the acidity of surface ocean waters has increased by over 30%. This increase is the result of humans emitting more carbon dioxide into the atmosphere and hence more being absorbed into the oceans. The amount of carbon dioxide absorbed by the upper layer of the oceans is increasing by about 2 billion tonnes per year. So consequently, the oceans have absorbed much of this increased heat. The Greenland and Antarctic ice sheets have decreased in mass. Data from NASA's Gravity Recovery and Climate Experiment show Greenland lost an average of 286 billion tonnes of ice per year between 1993 and 2016, while Antarctica lost about 127 billion tonnes of ice per year during the same period. The rate of Antarctica ice mass loss has tripled in the last decade. Glaciers are retreating almost everywhere around the world, including in the Alps, Himalayas, Andes, Rockies, Alaska and Africa. What has caused it? Coal, oil and gas are all fossil fuels. And when fossil fuels are burnt, they release carbon dioxide into the air. This is known as greenhouse gas because, like greenhouses, they create a hotter climate by trapping heat in our atmosphere. Now, we know all this, and we've known it for a long time. You hopefully know this already, although I do need to rehearse it here again in a context where the science is often denied or clouded by misinformation. Interestingly, though, we have known that this has been happening since the middle of the 1880s. So let's turn now to environmental degradation, including waste. Let's focus just on plastics. Each year, more than 8 million tonnes of plastic ends up in our oceans, and much of this comes from particles that wash off things like car tyres and synthetic clothing. At the rate we're currently throwing out single-use plastics like bottles, bags and cups, by 2050 our oceans will have more plastic than fish, and around 99% of seabirds will have ingested some form of plastic. Scientists are now studying the effect of microplastics on human organs in ways that have not yet been studied in the past. And it's troubling the effects that scientists are finding on human bodies. There are now said to be 5.25 trillion pieces of plastic debris in the ocean, with 46,000 pieces in every square mile. That's why 100,000 marine creatures die from plastic entanglement every year, plus around 1 million seabirds, and why 700 marine species might go extinct because of plastic alone. As for plastic on our land, well, we throw out so much plastic every single day, and most of those bags, bottles, packets and more are not being recycled. They end up in landfill, littering the environment, harming wildlife or blocking drains and increasing flood risk. And as we know, plastic doesn't break down. Plastic bags last so long, from 20 to 1,000 years. There are more and more of them in the litter stream each year, and in Australia only 3% are recycled. In the US, producing plastic uses 331 billion barrels of petroleum, a chemical that harms the environment by polluting air and water every year. Let's now turn to the third element. We've dealt with climate change, we've dealt with one example at least of environmental degradation and pollution, and now we're dealing with biodiversity under threat. As Professor David MacDonald has put it, without biodiversity, there's no future for human life. Why? Well, biodiversity refers to the biological diversity of everything from genes to species to entire ecosystems. Under 5% of terrestrial mammals are wild, and the remaining 95% is either us or our food. We are currently experiencing what scientists are calling a sixth mass extinction, the speed and magnitude of which is eclipsing that of the Cretaceous period that saw the extinction of the dinosaurs. This is quite incredible. Vertebrate extinction moved forward 24 to 85 times faster since the year 1500 than during the Cretaceous mass extinction. The magnitude of extinction has exploded since 1980, with losses about 71 to 297 times larger than during the KPG event. During that Cretaceous mass extinction period. So this is the opening of the door to part 2 of the lecture, where we look at how ecological economists have responded to this problem. Let's look to what Clive Hamilton, a professor of public ethics at Charles Sturt University, has written about this. If, in order to respond to global warming, we need a new consciousness, a fruitful way to understand the prospects for such a shift is to study the last major revolution in consciousness. And so Clive Hamilton suggests that we need to understand how we became radically disconnected from nature. Because if we understand that, we may be able to understand what it would take for us to become reconnected once more. Given that many of you are PPE students studying philosophy as well as politics and economics, you will have some access now to why we think the way we do and what ideas have informed that in the history of ideas. The entanglement of ideas, again in history. Ideas about ourselves in relation to nature. We've always thought, we've come to think of nature as a resource to be used, mastery over nature, reason surmounting nature. both in terms of science, grasping the laws of nature with our minds, and in terms of morality. Our morals have been about obligation to other people, interpersonal moral obligation rather than any obligation to nature. And this is something that Clive Hamilton thinks is implicated in the problem of climate crisis. So this is deeply embedded in our history of ideas, in the history of philosophy. It leads us to depict the problem as conceptual and theoretical as well. And we've seen that in this subject, haven't we? We've seen that the economic approaches that we've studied really do view nature as a resource to be used to support economic activity, and not as a limitation or constraint on that economic activity. This is not really surprising, given that classical, Marxian and neoclassical economics was formulated in an empty world. But ours is a full world now, on the verge of ecosystem collapse. So we've really come to this point because the conceptualisation of ourselves in relation to nature, where nature is to be mastered and used to support our pursuits and our desires and our objectives, our purposes. So that was my attempt to use, with Lily's help, with some of the slides that Lily has prepared for a previous subject, what I take to be the main problem of ecological economics. It's both a personal problem, it's a historical problem, and it's a conceptual and theoretical problem, all of them entangled together. So now we turn to part 2, the response. And this is where I'm going to draw on the required readings, changing their order somewhat in order to pinpoint 3 main responses that we can find in the work of the ecological economists. So in first place, a first response is a critique of popular measurements of well-being, like GDP, gross domestic product, or gross national product. And this you'll find in the work of Michael Jacobs, the first text that you're required to read for today. And the second response is an effort to revise 19th century theories, Marxian and neoclassical economics, to respond to climate change, to environmental degradation, to biodiversity loss. So this is an effort to revise those economic approaches which have in part been responsible for the very emergence of these problems. An effort to revise them to see whether or not they can still help to a certain extent. And so one of the readings you're required to read in the Stilwell and Argyris reader is an account of eco-Marxism, an eco-Marxist critique of capitalism by James O'Connor. It's a fascinating read, but I'm going to leave that for your own reading today, or you can discuss it in tutorials this week. And we'll also see, in addition to this critique of popular measurements, this effort to revise 19th century theories, we'll also see an effort to elaborate an entirely new economic theory, a radical interpretation of sustainability, which is also given a twist in being interpreted as a steady state economy by Herman Daly, or even a no-growth economy. I say entirely new because it does diverge in its conception of the relationship of the person with nature. It does diverge from the historical and traditional ways in which we've conceptualised nature as a resource to be used, because ecological economists will view the environment as a limitation or constraint on our behaviour, and not a resource anymore to be merely used for our purposes. You'll see in Herman Daly's text that he finds inspiration in some other writings of key writers that come before him, although I think he's been particularly generous in that regard, to be perfectly honest. Anyway, let's deal with each of these responses in turn. So we see a first response on the part of ecological economists to provide a critique of popular measurements of well-being, like gross domestic product and gross national product. So just to recall what gross domestic product is, it's a measure of the market value of all of the final goods and services produced in a specific time over the course of a year. Now, we've already noted in other weeks, particularly the week on feminism, feminist economics, that gross domestic product has difficulty incorporating forms of production and the value of production that takes place in the household, at home. We noted, for example, that breastfeeding is not counted in gross domestic product, but the purchase of formula and bottles is. And so we've already elaborated on some of the problems with GDP as a measure of well-being or production, even in other weeks. But here we have a different critique. If we're concerned about environmental degradation, the critique goes, then gross domestic product is a really odd and strange indicator. Because, wait for it, environmental degradation can often actually increase gross domestic product in the way that it's measured. And if you think about it a little, you can see why. Imagine that one lives in a town that has lots of pollution. This might generate a need for defensive expenditures. We might need face masks. We might need people who are working in the pollutant industries to be wearing protective masks to help them breathe, to get rid of the particulates in the air. We might also need to spend more on medical care. We might need to spend more on cleaning and repair products. And all of this counts towards GDP. Even though well-being is more or less, as Michael Jacobs argues, stationary. Alternative goods and services might have actually improved welfare, whereas this defensive spending on pollution control and repair instead works to use up resources to keep welfare exactly where it was to begin with. So you're spending money both producing and consuming, purchasing face masks, for example, or medical care to defend against pollution and keep your health at the same level as it was before, when you really might have been better off producing and spending on something that would have actually been beneficial to you. And Michael Jacobs goes on to consider the implications of this. Well, it means that GDP must actually be qualified in its measurements. We've got to recognise that if these measures are to be of any use to us in measuring welfare, then they have to register that they have to actually subtract defensive expenditures from GDP. The value of those defensive expenditures needs to be subtracted. And also, if pollution exists, but there is no defensive expenditure, then any residual damage to the environment that reduces welfare and has not been protected against by defensive expenditure should also be valued and also removed from current GDP. So it's a proposal to try to use GDP to actually reflect an account of welfare that makes sense, rather than one that merely registers the level of economic activity and not the effect of that economic activity on well-being. So Michael Jacobs in his text also goes even further to say, well, what we really need to do is to determine the objective of economic activity and then work out what sorts of measures we need to determine whether that objective is being achieved. So GDP doesn't really help us measure whether or not an objective like environmental sustainability is actually being achieved through production and consumption. So the second move is to revise 19th century theories, Marxian and neoclassical, to respond to climate change, to respond to environmental degradation and biodiversity loss and so forth. As I mentioned, there's a really interesting article for this week that I know a number of you will really enjoy, given your interests. This is an eco-Marxist critique of capitalism. So if I've previously suggested, and I did, didn't I, that Marxism emerged in the 19th century at the time of early industrial economies, in early phases of the Industrial Revolution. And this meant that Marxism was formulated in a comparatively empty world, where the concern was that increasing production should take place in a manner that could be consistent with the species being of workers who, under capitalism, had experienced alienation from the products of their labour. So when we looked at Marxism, we looked at it for its concern with the well-being of workers, for the species being of workers. And we didn't present Marxism at all as concerned in any way with environmental degradation or climate change. And that's kind of understandable given the historical period in which Marxism was formulated. But James O'Connor wants to say, well, Marxism can still be helpful in providing a critique of capitalism that shows why capitalism, by virtue of its very structure, gives rise to a host of problems, environmental and social, that undermine the state's capacity to actually respond to those problems. And he even goes so far as to argue that one of capitalism's essential problems is that ecologically destructive modes of capitalist production can in turn lead to the underproduction of capital. So he wants to try to show that Marxists need to be concerned with ecological destruction. Marxist, he thinks, can explain why capitalists should be concerned with ecological destruction, because it actually prevents capital from being as productive as it could be. So the analysis offered by Marxian economics could be expanded, James O'Connor claims, to provide an explanation of how ecological destruction prevents capital from being as productive as it could have been. Again, I'm not entirely convinced, but that's a separate discussion, perhaps, and I'm not going to go into it here. But what I do want to do is to tease out how neoclassical economics, which is what you're mainly taught, has also been used to provide a way of responding to environmental degradation, including climate change. And then I'll consider a critique that's offered by Sharon Bedder and ecological economists, so as to contrast ecological economics with neoclassical environmental economics. And again, this is part of trying to grapple with the sort of effort that we've seen by economists to revise these earlier 19th century theories of Marxian and neoclassical economics to make sense of and respond to climate change, environmental degradation, biodiversity loss, and so forth. So neoclassical economics, neoclassical environmental economics, I should say, is a sub-discipline of neoclassical economics. And for those of you who have done some economics so far, and I know some of you haven't, but bear with me for a moment, you will have already come across this circular flow diagram of the economy, where there are households and there are firms. There are markets for the factors of production that firms need to produce. Households will offer labour as a factor of production. Firms will produce goods and services that households want. And so there's a circular flow between these components. Where, you might ask, is the environment? Well, it's conceptualized here as a resource to be used. And environmental harm caused to the natural environment, is conceptualized as an externality. So environmental degradation, climate change, biodiversity loss, all of this will count as a negative externality. Let me explain what that means. In neoclassical economics, an externality is the impact of a transaction on a third party who's not directly related or involved in that transaction. So to provide an example, imagine that there's a coal factory producing coal and using water in the process. And then that water then feeds back into the river and pollutes the river. There may be some people fishing there. They are the third parties. The people who are fishing are not purchasing coal or energy. The household is purchasing energy. Those people who are fishing are not involved in the transaction of energy. But the people who are fishing are still affected by the transaction because they can't fish healthy fish anymore because the river's polluted. This is called a negative externality. It's those bad effects on third parties. But there are also positive externalities, like the positive externalities of education, for example. When people have an education, they are less likely to engage in crime, theft, and so forth. And this has a positive benefit on society. Education also has an impact in reducing teenage pregnancies with positive flow-on effects for the human capital levels of children. And again, all of the social benefits that flow on from that. So there are positive externalities from education that are good for third parties. And that's often been an argument in favour of government co-funding of education to the tune of the value of the positive externalities for society. So let's return to the negative externality for a moment. Let's say that you were going to sell a certain amount as a producer of coal, that the factory producer of coal, the producer of coal and energy is going to sell a certain amount of coal. But let's say X amount of coal costs $10. But now the pollution in the water has affected the livelihood of the people fishing, and that constitutes a harm that has a cost. And the idea is that the negative externality should be costed and should be actually factored into the price of the coal so that it reflects the true cost of the coal. And the idea is that if you actually look to the factors of production involved in the production of this good, there's also a social cost involved that should be factored in to the price of the good. Now, if you do increase the price of the good to factor in the value of that negative externality, you can see that the price of coal will go up. And the workings of supply and demand tells us, as we know from study of neoclassical economics in week 3, when the price of a good goes up, the demand goes down. So the quantity of coal that is going to be able to be sold is going to be less because the price is higher to reflect the true cost of coal. So how does this become implemented? Well, This is really the very standard orthodox mainstream way of dealing with climate change. So as Mankiw, Gans and King put it, and they write the textbooks for the Ivy League courses, while scientists can tell us the source and extent of the problem, greenhouse gas pollution is a classic case of a negative externality in production. So to solve the problems of climate change from a neoclassical perspective, we need to understand the best ways to deal with negative externalities. So what are these best ways, according to the neoclassical economists? Well, there are two ways that a neoclassical environmental economist would propose to fix a negative externality. And the first is with a tax, and the second one, which is discussed by Sharon Beder in your required reading, is the cap and trade scheme, or the emissions trading schemes. There's the carbon tax, which was proposed by Julia Gillard as the conventional remedy for a negative externality. Again, we're now sticking with the neoclassical way of approaching trying to factor in the cost of environmental damage as a negative externality. And this is the justification for carbon taxes. We need to do this work first before we turn to Sharon Beder's critique. So we saw Julia Gillard proposing a fairly mainstream neoclassical environmental economics approach to climate change, which was the carbon tax. The conventional remedy for a negative externality is a tax. A tax raises the price of the product that holds the externality, and as the law of supply and demand predict, when the price rises, the quantity sold is reduced. So in the face of too much pollution, putting a price on carbon will lower the rate of emissions. That's the first approach in neoclassical environmental economics. The second approach is that of an emissions trading scheme, another market-based approach to addressing the negative externality of carbon dioxide pollution. And in this respect, it's remarkable that an orthodox, conventional, uncontroversial in economics, market-based approach to addressing climate change was so controversial, politically speaking. And that's why you study PPE, isn't it? You don't just study how economists look at these issues or how a political philosopher might think through the same issue through the lens of concerns with justice. You also look at it through the lens of the historical path dependency of political institutions and what that path dependency means, given the existence of interests and interest groups on the ability of securing much needed policy change. But I'm getting off topic. In any case, like a carbon tax, an ETS puts a price on carbon. But instead of producers of carbon emissions being taxed per unit of pollution emitted, an emissions trading scheme instead creates a market where carbon credits are traded. This requires a decision to be made regarding an acceptable amount of emissions, which is then turned into the amount of permits available in the market. So really, again, this is another conventional approach. When a market exhibits an externality, that market is left to its own devices. When a market exhibits an externality and that market is left to its own devices, then the market will not reach equilibrium and it's considered a market failure. And so one really does need, in this conventional approach, to cost out that to price carbon in this way, to make sense of that negative externality. To say that again, when a market exhibits an externality, that market left to its own devices will not reach equilibrium and is considered a market failure. So the conventional approach is to try and overcome those market failures with market-based economic tools to rectify those negative externalities. But Sharon Beder, in your required reading, offers a critique of emissions trading schemes. And her critique goes like this. She says, in practice, cap and trade systems have only achieved limited emissions reductions. It only achieves the reductions that can be done cheaply. And if we think about it, you can see what she means. She points out that if industries that emit carbon are granted a certain amount of permits, those industries that are able to reduce their emissions cheaply will do so, and will choose to do so. And they can then retain those permits and sell them on a permit market. So the point is that the cap and trade systems don't compel industries to make expensive emissions reductions, because those businesses for whom emissions reductions are very costly and expensive can simply buy more permits from those businesses that can make those reductions very cheaply, and who will then be willing to part with their permits. So industries that cannot reduce their emissions very cheaply will really simply buy more permits at a cost, as long as it's at a cost that's less than it would cost them to actually reduce their emissions. And they'll buy those permits, off those firms for which emission reduction can be more cheaply achieved. So she says then that the analysis of how these systems have worked shows that the outcomes are really not that great. She thinks that the cap, which is the total amount of emissions for which permits have been issued, have also been determined not by what's technically feasible to protect the environment, but by vested interests and concerns about economic costs. And she provides a number of examples about emissions trading schemes that too easily commit phony reductions. This leads Sharon Beder to the conclusion that emissions trading schemes really will only work with the very sorts of enforcement and regulation that they were actually intended to avoid. The idea was that you could avoid the enforcement and regulation issues by leaving this work to the market mechanism. But Beder's point is that markets require regulation. They don't get rid of it. And this leads her to think, well, why not just have the regulation? So the third approach, and we've looked at the first two now, we're going to now go to the third. The third approach is an effort to elaborate an entirely new economic theory that diverges from these earlier approaches. And this will involve a radical interpretation of sustainability in the work of Sharon Beder. Beder thinks that sustainability has been co-opted by business in many respects, subjecting sustainability to economic interests, forgetting its radical roots. And we'll also look at Herman Daly's account of what sustainability in a radical sense would mean, and he argues in favour of a steady state economy, and I'll deal with each of those now. So ecological economics is deeply interdisciplinary, and it uses the tools of physics, ecology and economics. It recognises the role of complexity and the fundamentally intertwined evolution of human societies and natural ecosystems. It involves a shift in how we think about the relationship between the economy and the environment, So we saw the neoclassical approach depicted the economy in relation to the environment in a way that conceptualised the environment as a resource to be used. But for ecological economists, what we now see is that the economy is itself conceptualised as a nested system within a finite biosphere. You've got the economy within society, and you've got society within the environment. So the environment is now viewed as a limitational constraint. One of the reasons why I love this photo, and my kids have this on their wall, is because you really sense the fragility of our world and its uniqueness. And it's no surprise to learn that this photo, which was taken in 1968 by Bill Anders as part of the Apollo 8 mission, where the US was trying to beat Russia to be the first to have a human on the moon. It's no surprise to discover that this photo had a big impact upon the environmental movement of the 1960s and 1970s. You see here really how vulnerable Earth is and how precarious our existence is and how alone we are in the universe, how unique. There is no planet B. As one of my kids put in the climate strike, we only have one world. Economic growth on a finite planet. Think how different the world is now in comparison to the time before the Industrial Revolution. So as mentioned, the earlier theories, Marxian economics, classical economics, neoclassical economics, these were all formulated in a comparatively empty world. We hadn't seen the exponential growth in population that our earlier graph depicted. The economy really could be viewed, and it was more reasonable to view the economy in relation to nature as if nature was a resource to be used. There was so much of it. Now we have a full world where these problems are so visible to us. So yeah, as mentioned, this is the background in which neoclassical economics was developed. Ecological economics, on the other hand, draws on, as Herman Daly puts it in the article that's required reading for this week as well, draws on the laws of thermodynamics. So the idea of thermodynamics is that of how matter energy exists and changes. Its first law is that matter energy is not created nor destroyed, but only changes form, and it has a preferred direction. And this is the second law, entropy, disorder or chaos. This always increases, and it moves from low entropy to high entropy. So to have a stable system and a biodiverse, well-functioning ecosystem with its own order and interrelationships between elements that have developed over millions of years, well, it's risky to play with the elements involved. It's very easy to tip a stable system into an entropic, disordered and chaotic system. Drawing on Lily Falconer's work again, mainstream economics has a propensity to favour theories with a self-equilibrating character, simplicity and a tendency towards balance. But ecological economics doesn't. It recognises that the world is fundamentally complex, with feedback loops, tipping points, non-linearity, emergent properties, unintended consequences, and so on. The world is a complex, interconnected, finite, ecological, social, psychological, economic system. We treat it as if it were not, as if it were divisible, separable, simple and infinite. Our persistent, intractable global problems arise directly from this mismatch. We can see this with weather patterns and the increasing chaotic nature of seasons, temperatures and patterns. Drawing on these ideas and committing to the idea of a precautionary principle, which I'll say a little bit more about in a moment, Herman Daly decides to try to formulate a very different approach to understanding and organising economic behaviour. The idea is that because the economy is a nested system housed within the complex yet finite biosphere of Earth, it must abide by nature's laws. Infinite economic growth is not only undesirable, but fundamentally impossible. It also risks changing the nature of our world into one no longer of order with natural laws, but of chaos, of entropy. And thus, Herman Daly defends what he calls a steady state economy. The steady state economy is slower by design, not disaster. It decouples growth from development, dematerialising the economy. There's a tension here between efficiency and scale. So for example, in scenario 1, let's say that there's a fleet of 1,000 cars and each lasts 10 years. The new production would be 100 per year. In scenario 2, a fleet of 1,000 cars each lasts 20 years. The new production would be 50 per year. Which scenario would be better for our economy? Well, if we're measuring by GDP, it would surely be the first. But which is better for us and our environment? Well, surely it would be the second. So the idea is to try to be slower by design. Daly also provides further support to Michael Jacobs' concern with GDP and instead develops a genuine progress indicator rather than a gross domestic product indicator. The genuine progress indicator is one that subtracts from GDP the measures of economic activity that are detrimental to the environment and to economic welfare. This is an index developed by Herman Daly and John Cobb as an alternative to GDP, where genuine progress indicator includes, on one hand, the sorts of things that GDP itself measures, but it then also subtracts the cost of crime, the cost of family breakdown, the cost of underemployment, water pollution, and so forth. This is an index of sustainable economic growth. Here's a slide that maps that out for you a little more. So in some, ecological economics and the steady state economy is meant to recognise the biophysical limitations of our planet. It intends to decouple growth from development. It seeks to incorporate more human-centred measures of well-being that recognise the fundamentally complex nature of the world, viewing the need for an economy that is inevitably regulated by the laws of physics. And Daly and Cobb believe that this means that the economy would be of a mixed economy characteristic. We've now into part 3, where we look at the questions: who wins, who loses, and does it matter, applied now to theory itself. But we've already gone past the hour for this lecture, and I know your concentration will be going. So let's potentially deal with this in the tutorials. So I'll say good night and thank you for remaining with me until the end and for